Hello, and welcome to The Cognitive Revolution, where we interview visionary researchers, entrepreneurs, and builders working on the frontier of artificial intelligence. Each week, we'll explore their revolutionary ideas, and together we'll build a picture of how AI technology will transform work, life, and society in the coming years. I'm Nathan Lebenz, joined by my co-host, Eric Torenberg. Hello, and welcome back to The Cognitive Revolution. Today, I'm excited to share my conversation with Anastasis Germanidis, CTO of Runway ML, a company that's become synonymous with AI video footage generation, and which, with their latest Gen 3 models, continues to lead the video generation market. Joining me as co-host for this episode is my good friend Stephen Parker, creative director at Waymark and co-creator of the AI-generated film The Frost, which we've covered in a previous episode. As a power user of a great many generative art tools, including Runway, Stephen brings an extremely valuable perspective to this conversation. I came away from this discussion really super impressed with Anastasis. We threw a lot at him, and he gave very nuanced, thoughtful answers on a wide range of topics, including video generation models as world modelers and the potential role of video understanding on the path to AGI. Emergent properties that Anastasis and the Runway team have observed as they've scaled up their models, including surprisingly accurate liquid simulations and improvements in 3D consistency. Runway's product development philosophy and culture of rapid iteration, including how they think about shipping upgraded models even if they might disrupt existing user workflows. And of course, the challenge of scaling to meet explosive demand. We also touch on the creative possibilities unlocked by these tools, from pre-production storyboarding to generating footage for use in final productions, the importance of data quality over architectural complexity, the potential for the next generation of models to incorporate audio, the intriguing possibilities of interactive AI-generated environments, how all this technology might shape the future of entertainment and culture more broadly, and even how Anastasis thinks about competing in a game of scale with tech giants who have functionally unlimited resources. In Runway's innovations, we can clearly see signs of things to come. Democratizing access to high-quality video creation means more stories from a wider range of voices, but also potentially major economic disruption for the iconic American film and television industry. As always, the pace of change is relentless. Since we recorded this episode, Runway has indeed launched API access, and we at Waymark are super excited to be among the first wave of customers to try it out. If you're finding value in the show, we would love it if you take a moment to share it with friends or leave us a review on Apple Podcasts or Spotify. And of course, we welcome your feedback via our website, cognitiverevolution.ai, or by DMing me on your favorite social network. Now, I hope you enjoy this illuminating discussion about the technology behind and the impact to come from AI video generation with Anastasis Germanidis, CTO of Runway ML. Anastasis Germanidis, CTO of Runway ML, welcome to the Cognitive Revolution.
Great to be here.
I'm excited for this conversation and also excited to have my teammate and friend Stephen Parker, creative director at Waymark, along for this episode. We're going to get into generative AI for creative work, and he is an expert in that with a film that we've covered in a previous episode, The Frost, now traveling the globe and making its debut in Singapore. I will be the least knowledgeable about what is going on here today, but excited to have this conversation. I thought we would start with a big picture discussion of video generation as world modeling and as a step on the perhaps critical path to AGI. I'd love to hear your perspective on the case that video generation really is something that we have to have on the way to an AGI destination.
So humans are visual beings. Like, being in the physical world is a fundamental aspect of being human. And you can formulate so many tasks humans do in the modality of video. So the world models is like, as those models basically learn through video data and large volumes of the video data, they gain powerful representations of the 3D world. They gain representations about a wide range of human activities, of different tasks that you can perform in the world. And so that knowledge can be leveraged to generate video, which is where we came from, but also for a variety of different other tasks. Video models will kind of power huge applications in robotics to build representations of the world. One framework I like to use is that every representation of the world, like whether it's video, whether it's language, whether it's another representation, it's ultimately a proxy for reality. But video itself has much less inductive biases than text, specifically the text that language models are trained on. Text captures a much smaller subset of everything that humans care about compared to video. So that's, in a nutshell, kind of the case for why video generation can lead to broadly useful general intelligence and how we're thinking about it.
So a lot to unpack there. A couple just follow-ups in different directions. One might say, is video enough? If you're to take that argument, could you say maybe we need actual 3D point grid representations of the world? Is it a matter of just video being abundant relative to an even richer modality that makes it the natural place to work from? Or do you think that video is in some way a threshold that means it can do similar things as if you had a full 3D model?
So what we found is that you can essentially learn 3D, you can gain 3D knowledge simply from the 2D footage. Models like Gen 3 have remarkable 3D consistency. Like if you're generating a camera moving in a specific direction, essentially you'll see things in the environment remaining consistent as you'd expect from a 3D point of view. We think 2D representations are sufficient to capture 3D knowledge. 3D data is really hard to find at scale, and that's why generally research in 3D computer vision has not advanced as much as it has advanced in the 2D domain. So those are the two main arguments. There is the abundance of video data and the fact that you can derive 3D representations from 2D data that makes video a good candidate for learning those broadly useful representations.
When you mentioned object consistency, that definitely reminded me of OpenAI's statements that the things like object permanence and the sort of intuitive physics that seem to get better with scale. I believe their phrase for describing this was, these are purely products of scale. I wonder what you would say have been the most interesting emergent properties or behaviors that you have seen as you have scaled up. Like what has jumped out and surprised you that you didn't necessarily engineer into the system, but nevertheless observed?
That statement definitely aligns with what we've seen as well. If you compare, we released Gen 2 more than a year ago. We released Gen 3 recently. If you compare the outputs from the Gen 2 model to the outputs of Gen 3, there is a large step up in capabilities. And a lot of that can be attributed to compute. There's a lot of other things that we did differently as we were building Gen 3. We've seen a lot of interesting emerging capabilities of Gen 3. Some interesting things on the world modeling side are the ability to simulate liquid simulation being surprisingly more accurate than you'd expect from a model that has no prior knowledge of how liquid should behave. There is specific prompts that we try to understand those capabilities, like the interaction between a boiling pot where you throw out water on the boiling pot. So those kinds of interactions reveal some really surprising physics knowledge embedded into the model. And that's all completely learned from data, learned from scale. There's no specific inductive priors that we introduce to the model to make it follow the laws of physics. There is a lot more room to further improve those things. The model doesn't fully follow the laws of gravity perfectly. Like even generating something like a bouncing ball can be challenging. So I don't think the problem is fully solved. But if you see the delta between 2 and Gen 3 and you extrapolate from there, I don't see a fundamental reason why that additional physics knowledge and a more precise understanding of the world is not going to emerge.
How much do you think the architecture matters? Different companies have given different amounts of windows into their architectures. Do you think that the different big efforts to build these sorts of models will converge and ultimately have a similar architecture that is found to work the best? Or do you think there is room in the space of possible models to see divergence with different strengths and weaknesses?
There's definitely more algorithmic improvements to be made. I don't think our collective explorations of the field of possible architectures has reached a conclusion. Of course, there is a lot more convergence to transformers and convents, and it's a very small set of architectures across modalities. At the same time, I do think there's been traditionally much more focus on architecture compared to data, objectives, tasks in the field of machine learning. If you look at the most recent computer vision conference, and take kind of survey of all the papers, you'll see there is probably a disproportionate focus on architectures than on other aspects of training those models. Data is really important, specifically the tasks that you're teaching the model through data is something that there's probably less published work on as much as architecture.
Have you studied CANS at all? That's the Kolmogorov-Arnold network that's out of Tegmark's group at MIT. Ziming Liu is the first author. The reason I bring it up is they've created a way to learn activation functions, and now they've also created a way to initialize these networks with specific activation functions that can encode a whole range of useful physics operators into a network. It seems like, to me, an extremely promising neurosymbolic approach. If you've seen that, great. If not, I wonder if you have any thoughts on embedding into future architectures things that would be like obvious calculations that one might want to actually run simulated physics. Obviously, you said gravity's not perfect. If you could build in a parabola operator into the network, presumably that would help with getting these fine points dialed in a little bit more. Any thoughts on that?
I'm not very familiar with the paper, but I think something that very often happens with a lot of kind of new architectures that supposedly perform common architectures, and we saw that with myriads of different alternative forms of linear attention. At some point, that was a big focus of the field, just figuring out if there is a more efficient mechanism of attention. Very often, the way those are presented in literature can lead to wrong conclusions. One very common thing is comparing the performance of two models with the same number of iterations, but not take into account that those models might have different amount of compute per forward pass. So there's all those different things that end up confusing the overall conclusion from a paper. It's really hard. There's a lot of people working on improved architectures, and generally it's very rare that you find something that outperforms the current architectures. I think there's definitely room to improve on what we have, but I'm generally, it's good to start from a place of kind of
don't get too excited on the first paper.
And I would say not infusing too many inductive biases or prior knowledge into the models, and instead choosing data carefully or choosing kind of the whole training regime carefully. I think it's a much more scalable approach, or at least that's what we found.
It sounds like you're saying almost kind of, I hear echoes of Ilya, the models just want to learn. Don't think too much about the architecture, easy to overcomplicate it. What really seems to matter is data quality, scale, and letting them do their thing and facilitating that more so than trying to engineer it into them. I wonder if you have a take on another recent paper I'm obsessed with, the Platonic representation hypothesis, which seems to suggest that with scale, models are gradually converging in terms of the way they represent concepts internally. I guess I'd be interested in your take on that. How do you think about that as it may or may not have implications for the strength of multimodal models? I wonder if that pushes you to think maybe we should do more than video. What are we missing that textbooks or long math proofs might be bringing to the overall data set if we're primarily just focused on a video training corpus?
Yeah, I'm a big fan of that paper, and I was sort of alluding to it earlier on. Basically, the main idea is as you scale models of different modalities, they converge into similar representations, and that's argued in a few different ways. One very interesting argument is that as you scale models, they arrive at simpler solutions to problems. I'm not necessarily suggesting that video needs to be the only modality that you train on. I'm saying it's a more general modality than text. So you can imagine models that are trained on many different modalities, and each modality maybe has a specific aspect of reality it captures in a more compact, useful tokens. So I'm not opposed to the idea that you can train on different modalities that have different strengths rather than training just on video or just on text. But I think the focus on text as the modality that would lead us to general intelligence may be misplaced. And a lot of what we're trying to argue from the Runway research perspective is that video tokens are really useful and reveal so much of the world that's not actually captured text corpora and the main argument. But I do think ultimately, as we're getting closer to more generally intelligent systems, they will need to be able to utilize different modalities.
Can we dig in on that for a second? I was thinking that mixed modality is really a huge thing for you guys coming up soon, I would imagine. There's sight and sound in video, right, as crucial components. And the idea of a mixed token training regime seems like a fascinating prospect for the future. How do you guys think about including sound as you go about this?
Yeah, it's definitely something that we're going to do at some point. I think our focus has been really making sure we can get the visual quality and visual generation to be as good as possible. I think we haven't saturated the improvement there, that right now it's beneficial for us to focus on just visual modality. I do think eventually generating both frames and sound associated with those frames is definitely the next step, but there's just so much more to do on getting video generation quality to be better, and many interesting problems to solve along the way. That's our primary focus, but eventually you want to generate both. I agree.
Hey, we'll continue our interview in a moment after a word from our sponsors.
As a Cognitive Revolution listener, you're obviously interested in cutting-edge AI technology. And with that in mind, I'm proud to say that this episode is brought to you in part by Notion. Notion has been a clear leader in high-value applications of generative AI since the wave began. Earlier this year, we had Notion AI engineer Linus Lee on the podcast. The quality of his insights showcased the caliber of talent that Notion employs. And that inside look at how Notion builds with AI is still extremely valuable. Given my personal focus on AI automation recently, I specifically wanted to highlight Notion's library of workflow and automation templates. If you're looking to streamline your processes and lay the foundation for future AI-driven automation, these templates are an excellent starting point. And even if you're not ready for full automation, you'll benefit immediately from Notion AI, Notion's latest all-in-one AI implementation that searches through thousands of documents, regardless of whether they live in Notion or on some other platform like Slack or Google Docs, to deeply understand the context of your work and generate highly relevant analysis and content just for you. Notion is used by more than half of Fortune 500 companies, helping teams reduce emails, meetings, and time spent searching for information. Want to try it? Head to notion.com/cognitive revolution. You can start for free, and using our link supports the show. So join me in giving Notion AI a shot today at notion.com/cognitive revolution. As a developer, the journey from concept to production-ready large language model apps is fraught with challenges. Dealing with unpredictable language model outputs, hallucinations, and ballooning API costs can all be blockers to shipping your next AI-powered feature. That's where advanced RAG comes in. With the new RAG++ course from Weights and Biases, you can overcome these hurdles and build reliable, production-ready RAG applications. Go beyond proof of concept and learn how to evaluate systematically, use hybrid search correctly, and give your RAG system access to tool calling. Based on 21 months of running a customer support bot in production, industry experts at Weights and Biases, Cohere, and Weaviate show you how to get to a deployment-grade RAG application. This offer includes free credits from Cohere to get you started. Make real progress on your large language model development and visit wandb.me/cr to get started with their RAG++ course today. That's wandb.me/cr to get started with their RAG++ course today.
Do you think of yourselves as an AGI lab at this point? I wasn't quite clear on, is the case that this is going to be important and we are going to go do that. I wonder, I also imagine too, there must be some interesting tensions between, when I think about all the stuff that people are generating with Runway today, so much of it is fantastical, impossible, magical. There's seemingly a notable divergence between what I would train on and what I would want to empower people to do if I was trying to allow them to make films to entertain people, versus if I was trying to maximize my universal physics simulation abilities. And that seems maybe fundamental. Is there a sort of magical realism token that gets put into the mix at some point to distinguish between when the rules of physics are supposed to apply and not? I also wonder if this has any relation to why OpenAI hasn't launched their thing hardly at all to date, because maybe they're thinking, we don't really care about making films, we just want to simulate the world. They can maybe afford to do that with the resources they have. Are you an AGI lab? Do you feel a tension between realism and surrealism? Any other speculations would be most welcome.
Yeah, we're not an AGI lab. I think the definition of AGI has been very unclear to me.
Define it for yourself if you want to declare yourself an AGI lab.
But I think there's a lot of other terms that are more useful to us. I think a lot of how we see ourselves is augmenting human intelligence and augmenting creativity versus trying to build agents that are generally intelligent. I also think if we take Turing test as the criterion for AGI, we can trace discussions on AGI back to the Turing test. And that's such a noisy test to determine intelligence, like whether someone will perceive a system to be intelligent or not. So I do think something more useful than achieving AGI is building more capable simulators of the world and being able to simulate different aspects of reality. I don't necessarily think of it as one milestone where we've sufficiently simulated reality. Reality has an infinite amount of complexity and detail at different levels of abstraction. Something I don't like with AGI as a goal is that it kind of enforces that breakpoint where once you get there, you've achieved AGI. For me, it's a much more continual progress narrative. So a big focus for us is really extending human capabilities. The other part that I find trouble with the AGI concept and discussion is the way I think about humans and human capabilities is directly tied to technology. With every new technology, every new system that we build, we're extending what it means to be human, suggesting that there is a moment of parity where like we've achieved parity with human intelligence. For me, doesn't quite make sense if human intelligence also changes over time with technology. So broadly, my thoughts on the AGI topic. To your second question of whether building those world simulators is compatible with the creative use case we're focusing on, I don't think it's incompatible. My argument for that is that as the models get better, essentially they're learning a data distribution. And as the data increases in scale, they're increasingly approximating kind of reality. In some ways, as the models increase in capabilities, they learn a wide variety of tasks, and you can combine those tasks in novel ways to create things that are out of distribution technically. As the models improve, the way they can go out of distribution becomes more interesting. So in a way, the better those models become, the better they also become at creating novel combinations of things. You can see that with a lot of AI images and videos. They're combining concepts in ways that have not been combined before. That comes from really learning those individual concepts well from data. So the better those models become, the better they become essentially hallucinating, which in our case, it's a useful property to have. We want the models to be grounded in some capacity in terms of understanding language well and user intent as you're creating with those models. But we also want them to be imaginative and arrive at novel combinations of concepts and create videos that do not seem similar to any videos created before. You can see that with a lot of the outputs from Gen 3, you can generate moving through an environment and opening a door to a completely different environment. And the model is able to reason on like how to create those very unlikely outputs just because it has really learned the constituent parts of what you're trying to generate really well. And is able to combine them in novel ways to create the final output.
Have you done interpretability on your models? In the large language model space, of course, there's been a lot of interpretability. There's been sparse autoencoders coming online recently that show distinct concepts that are operative at any given point in time. I was joking a minute ago when I said, is there a magical realism token? But it strikes me now that perhaps not a magical realism token at the input level, but a magical realism learned concept somewhere in the 80% through the model range actually might be quite likely. Have you had a chance to go that far, apply any of these interpretability techniques to what you've created?
It's an area I'm very interested in. We haven't done as much work on that area, but it's something that we're investing more efforts on. I think it's really interesting to understand what the concepts are for those models, and it becomes even more interesting in the visual domain because from a controllability perspective, it's powerful to detect magical realism token. Now you can activate it and ensure that your generations will have the qualities that you want. But I think it's a super interesting area. We don't have too much to share on that yet.
Yeah, I can imagine the Golden Gate experience where The Golden Gate Bridge shows up in every teacup, no matter what the prompt was. I mean, again, if all these things are converging, it stands to reason that probably is not too far off into the future. You said, we're not trying to create agents. How long does a video clip need to be before there is an implicit agent in the little people that are being simulated? It seems like at a 10-second window, you maybe can get by with stochastic paratree. It can be imitations of other things that it's seen. But if you intend to extend the length of what can be generated into longer and longer scenes, it seems like at some point there is likely to be little agent type ephemera arising in the process of just predicting what the character is going to do next. Does that seem too far out for you to entertain at this point? Or do you actually think there could be little proto-ephemeral agents hanging out in the models?
If I understand what you're saying correctly, you're saying, like, let's say you generate like a egocentric video. Essentially, you're like a day in the life of someone. As you generate a long enough video, you'll see the person taking different actions in the world. And in order to predict those actions correctly, you essentially need some implicit model of reasoning capability to decide what actions to take or how to respond in the world. I think that's very plausible. As those models scale, increasing capabilities, that definitely, I think, could be the case. I think what's interesting from my perspective is if you can continually provide user input in that generation, and you can control it in different ways to either create an interesting output, or if you can going into more on the interactive media side of things, which I think is one of the most interesting applications looking to the future of video generation, is creating interactive experiences and seeing those models as new kind of rendering engines or game engines. So those are the things that we're more focused on, but I can imagine those reasoning capabilities would emerge at sufficient scale because it's problems that you need to solve to effectively simulate that kind of long duration videos. I think it's really interesting.
You can file this under yet another reason that I continue to find it more and more plausible that we ourselves are living in a simulation. Thank you for going on this journey into the world modeling possibility space with me in the first half. I think it's probably a good time to switch gears and let Stephen take more of the lead, talk about the actual product and how it's being used and the augmentation and philosophy of art. I mean, there's a rich set of things to unpack there too.
Thank you for agreeing to do this. I'm an avid user of Runway and a former New York startup person myself. So I think at the beginning, just to rep as a fan for a minute, maybe you could talk about the culture of shipping that you guys have built. You're obviously quite prolific out in the world these days, and shipping changes all over the place. Where does that come from? How do you think about that? How important is that to everybody back at the office?
It's very important, and it's something that we paid a lot of attention to from the very beginning when it was the three of us. At that point, it was almost an existential thing. If we didn't keep shipping, nobody would care about us, and we needed to keep reminding the world that we exist. These days, the technology is moving so fast that it's really important for us that the community that use our tools, our users, are able to follow along with the progress of the technology. We always felt that by continuously deploying newer models, newer techniques, newer tools, it reduces that lag in terms of our perception. So I do think kind of shipping continuously is really part of the DNA of Runway. And it also builds really great momentum internally. If like you continuously are seeing the things that you create being used in all sorts of interesting ways that you can expect by kind of the creatives and the artists using the platform. That momentum has sustained us, and it's something that people that work inside Runway have as one of their favorite aspects of being at Runway. It's the ability to see research being translated into amazing films, amazing artworks really quickly within the span of weeks or months, depending on the specific tool.
Listeners might not be aware, as well as some users, I would imagine, that you guys actually have a whole wealth of tools, right? You've got stuff for color, reskinning with other styles. There are quite a few video tools inside of Runway, some of which happened before you guys even created the now more famous Gen video tools. So how do you think about keeping up with all of that older tech or tools hanging out in the system, especially now that you guys have gotten super popular with the video generation? just in terms of priorities and what people want from you? I can imagine you were just sort of trucking along, shipping for a while, and then one day you have these incredible gen video models that everybody wants to use. How do you balance and react to that?
The first point is that we were interested in generative models from the very beginning. It's just that the results and the quality of those models was not quite there to build tools that people could use in production or in other use cases. So in the first years of Runway, we had parallel efforts, one on the research side, and then the other one is more the product and tool side. And we tried to improve image generation models, video generation models. At that point, those two parallel paths intersected. We're like, this is good. It's not perfect, but it's good enough that you can build some really useful tools around those models. Generative models were an interest of ours from the very beginning. When we started in 2019, video generation was not quite usable. The second part is a framework. I like to use this in terms of the outcomes of those tools versus necessarily the tools themselves. Whether you use generative models or more traditional computer vision to achieve those outcomes is less important than achieving those outcomes. One example is one of the most popular tools in the pre-generative era was our green screen tool, which was essentially an interactive segmentation tool. So you can select a specific object or subject in a video and separate it from the background. That's a fundamental aspect in the way video editing and VFX work has been done for a long time, but it's not clear to me that it's going to be a fundamental aspect of video editing if we look into the future. You can achieve the same goals, which could be that you want to apply an effect on a specific part of the video, maybe just the background, or you're essentially compositing as part of the pipeline, and it's not the final thing you want to do. It's more something that you need to do to get to your goal. And if you can do that final thing without the intermediate step of compositing, then that's a much better workflow. And that's what I think the generative models will enable. Right now, I think we're nowhere quite where we need to be in terms of the ability of those models to understand intention, but I don't see any technical reason why it's not going to happen. And so you can imagine all those editing operations that we had a collection of different tools to perform, you can now do with a single tool or a single interface. So that's how I'm thinking about it. The generative models will eventually be able to handle a lot of those tasks that you need individual computer vision-based tools to achieve.
Yeah, when I first saw, I think it was Gen 1, I imagined it was like a pipeline assembly from smaller tools, potentially leading up to the output video at the end. Maybe that's not how it works at all. How much of those early tools helped you guys develop this later stuff? Or are these gen models really like living on their own in isolation, their own sort of unique training?
So the way to build those models is quite different than the way we were building the tools before. But the early tools really helped us gain a lot of knowledge about what was important in video editing, what people really cared about. And that knowledge definitely transferred to the kind of gen model tooling. I see them as one kind of continuous discovery process towards where we are now. But the way to build those models, it's much more complicated pipeline to get to Gen 3 versus the model that powered green screen.
Hey, we'll continue our interview in a moment after a word from our sponsors. Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount. AI might be the most important new computer technology ever. It's storming every industry, and literally billions of dollars are being invested. So buckle up. The problem is that AI needs a lot of speed and processing power. So how do you compete without costs spiraling out of control? It's time to upgrade to the next generation of the cloud, Oracle Cloud Infrastructure, or OCI. OCI is a single platform for your infrastructure, database, application development, and AI needs. OCI has 4 to 8 times the bandwidth of other clouds, offers one consistent price instead of variable regional pricing, and of course, nobody does data better than Oracle. So now you can train your AI models at twice the speed and less than half the cost of other clouds. If you want to do more and spend less like Uber, 8x8, and Databricks Mosaic, take a free test drive of OCI at oracle.com/cognitive. That's oracle.com/cognitive. oracle.com/cognitive.
In turning a little bit to features. There are obviously these gen models that people take advantage of inside the product. They're surrounded by a range of features, right? And those features might be things like camera zoom in, camera zoom out, pan left and right, things that force instruction in the model. And then as later models come out, those features aren't always there, but there might be more adaptability in the text prompt itself, right? I have more luck as a user saying zoom out from here or pan right just in the text as opposed to a hard tool. How do you think about the release cycle? We have a new model. It doesn't do all aspect ratios yet. It won't respond to all the tools yet, but it's better in all these other ways. We want to go ahead and release it. The world seems to be okay with that cycle now, but I can imagine a future where users are like, I want the next version, but I also want the full set of tools that I had along with it before. How do you guys think about adapting to that and rationalizing through that process?
The first thing is something you alluded to, is that there is such a big advancement from each model iteration right now that not necessarily all the tools and toggles and sliders that were part of the previous model will be relevant for the next model. So I don't think we're at the point where if the new model was better on the kind of more marginal, like incremental ways from the older model, then I think there's a stronger case that we need to make sure that everything that was part of the previous model is now part of the new tooling. But right now, it's such a big kind of delta of improvement in quality, consistency, and so forth, that it makes sense to, like, it's useful today, even if it doesn't have every single controllability aspect of the older model. And having to wait for that would probably make a disservice to our users who want to get advantage of all the capabilities of the newer model. So it's not as big of a consideration to reach parity. At the same time, if older aspect of controllability or feature of a model is still useful for the newer model, we want to be able to provide it, and we're working towards adding a lot more capabilities to Gen 3 than even the totality of features of Gen 2.
Got it. That's maybe a good segue to the power users of the product. I can imagine they're myriad, but who are some of the strongest representatives? Video means a lot of things to different people. It can mean stock, it can mean film, it can mean commercials, it can mean games. Who's the loudest voice in the room right now?
So we have a wide range of customers and users. So from smaller studios, larger ad agencies and film studios that are using the platform, to a wide range of kind of individual creators. I think it's very interesting kind of new emerging kind of genre and culture that's emerging around AI video that we really want to support. And we do that both within the tool, but also with the AI Film Festival. We do 48-hour film competitions. We really want to support and grow that group of creators embracing AI tools and methods. I think that's only going to grow really fast.
That stuff is super cool, by the way. It's like a hack weekend for creators. I think a lot of people really enjoy that.
And we have the next one coming up soon, in the coming days. We've had over, I think the latest count was something around 1,800 teams that signed up to participate. Really excited about this new group of creators that are embracing those tools. There's a lot of interest from the enterprise side as well. As I mentioned, film studios are using Runway in different parts of the workflow. We have ad agencies that are using Runway in different ways. You can use it in different parts of the production process. It's really useful in pre-production for storyboarding, for getting to the 80% version of your final campaign or film. And we see a lot of usage for that. Even if the output is not fully usable in the production, it's still really useful to really give, communicate internally, what does the final result look like. But with Gen 3, we actually saw a lot of the outputs being used in production as well. Again, a lot of limitations to being able to fully generate every shot of a film with a model like Gen 3, but you can generate B-roll footage, you can generate parts of the final result.
Can I ask you for hot takes on a couple of recent topics? Game engine, the Doom player, have you seen the paper and video for that?
I have.
The first time we've seen interactivity along with the video.
Really interesting work. We're really excited about this direction of building interactive engines using generative models. I think what's especially interesting with them is the ability to generalize. You can essentially create a video game from scratch from a prompt. That's a direction I think is really interesting, being able to navigate worlds that you're creating as you're navigating. One aspect of this paper, which I'm less excited about, is that it's essentially trained on a single video game. If you take the size, the Doom video game is probably a few megabytes. The diffusion model was trained based on frames from that video game, is on the order of gigabytes. And so from an efficiency point of view, I don't think it makes much sense that you would use a diffusion model to generate scenes from that game, especially if you don't have that aspect of generalization, which I think is, to me, is the most interesting part of this, the ability to, if you could create variants of Doom that follow your prompt, that would be super cool. But if you're just generating the same footage from the same game, it just becomes a less efficient game engine. Overall, really excited about the direction, but I'm not sure this is the best proof point for it. There was a paper that I found really exciting recently called Genie. I don't know if you've seen it, but essentially you can generate arbitrary platform games and control them. And it's also a video generation model, but I think there's something really compelling there, which is it can generalize to new environments as well. That's the direction I'm most excited about.
Maybe the last thing for me is just more on that culture of shipping, but on the culture of scale. What has it been like for you guys to go from small startup to a demand that I can't even imagine dealing with in terms of the product? I mean, people want more and more from you, right? They want faster gens, they want more gens, and you have to figure out how to make it all work. What's that like?
Yeah, it's been really exciting. I think the thing that we've emphasized from the very beginning and a big part of our culture beyond shipping is learning fast, learning new aspects of building tools, building technology that the team might have zero prior experience in. And I think that's been the most exciting thing about building Runway is that it's almost been a different company every year. The things that were important to get right every year are different. The ability to scale model training to build a model like Gen 3 is something that we didn't have a lot of prior experience in. We had to learn a lot of things as we were working on it to get that to work. That aspect is really exciting. We try not to scale too fast from a kind of people perspective. We're still a fairly small company considering our stage in the market, and that's very intentional. I think we try to be always smaller than we need to be, essentially. And another aspect that I think is really important to scale effectively for us has been that all leadership, all management is very technical. Getting the details with the tools and the models that we're building is the most important thing. That can only be accomplished if the leadership is hands-on and really is one of the people working on the technology.
Cool.
One question I've been pondering as I've listened to this last exchange is, you've given a few glimpses of your vision for the creative future in terms of interactive experiences. Another big question that looms large over all this is this something that ultimately is a total leveler, or is it something that still is best wielded by the real pros? The reason I definitely wanted to have Stephen here is that he has made films for years and has made all kinds of creative stuff for years, whereas I, in first grade, knew that I was not going to be an artist. That was the first thing I knew I wouldn't be. And that difference is I would say the gap is probably somewhat closed. In general, the research on who benefits from AI and how much seems to show that the low skilled often can be brought up. The very skilled, at least when it comes to language models, don't necessarily get too far ahead, or like the very best coders don't necessarily solve problems they couldn't previously solve. Creative might be quite different. I mean, I can go in there and make something and it can be cool. I still am not on Steven's level, but he is maybe on the level of a Hollywood studio, which is another kind of leveling. So where does this all end up? Are we all headed for a world where anybody can sort of conjure up their own feature films? Do we still have specialists? If so, like, what is the nature of that specialization as the tools mature?
I want to take a starting point to something you mentioned of like the pros not benefiting from language models or code gen models. I think pros definitely benefit a lot from things like Copilot or Cursor more recently, being able to give you context to know like instructions, like how to formulate kind of a project. And you can leverage those models to really expand and speed up your workflow. Maybe you'll be able to implement it on your own and you wouldn't need those models necessarily, but having those models speeds up the choices that you can make. I think it's the same with creative projects. Like taste and vision is as important with those models as it is with more traditional filmmaking workflows. That's not going to go away. There's always going to be people that create things on a different level of quality or vision than others. It will help people who might not have prior experience express themselves through filmmaking or making videos. I don't think that gap is going to necessarily close. I think what those tools allow you to do is turn your ideas into a final output much quicker than before. They allow you to make a larger amount of choices in a shorter period of time. The choices that you make along the way are really what defines the final output, and the knowledge and the kind of insight to make those choices really matters. We're seeing that some people invest a ton of time and effort into becoming great at using those models, and that effort pays off.
In the kind of zoomed out strategic analysis, it's take a lot of your comments boil down to scale really matters. That seems pretty clear. How do you compete long term with the trillion-dollar companies that have billions and billions to burn to scale up? Is there a time coming, like the word from Anthropic, for example, allegedly from their leaked memo, was that they think in 25, 26, the leaders may get so far ahead that nobody else can really catch up to them because they'll have the best models, and the best models will be useful to train the next models. They'll generate all the revenue. From that position, will you have the chance to do the $10 billion training run and beyond? Do you see similar dynamics happening in the creative gen space? And if so, does that mean you're just going to have to raise billions of dollars over the coming years? Or is there any other way that you can see that playing out?
I think you need to spend a larger amount of kind of resources, and the barrier to entry becomes much higher very quickly. We need to keep up with and make sure that we stay ahead and make the investments in compute in order to train those larger models. At the same time, scale matters, but it also matters what kind of framework you're trying to scale and what's the task that you're trying to teach them all to perform. I do think there is maybe less focus on that as there should be. I see a lot of companies that are trying to scale the exact same thing, which is a very specific paradigm in LLMs to really achieve certain numbers in the same benchmarks. I think it's important to apply a lot of compute to train models, but compute is not the only thing. It's really, what are you training those models to do? What are the tasks that you're focusing on? There is a lot more to do there that might give you the right insights on that front, can save you order of magnitude more resources. So that's broadly how I'm thinking about it. I don't think scaling is the thing that improves models' performance, but what you're improving the performance on really matters. That's something we have some unique insights on and a unique perspective on that's not shared by the rest of the industry.
I heard something recently from a team member at one of the big three language model companies that surprised me a bit. And basically the person said, we expect divergence of models over the next generation or two. Because I've had this kind of paranoia on the language model side, especially if like platonic representation and if there's generally this sort of convergence, then we might end up in a very high stakes situation where one new model comes out, it's essentially the same as the last one, but just a bit better. Everybody switches to it. It can create a winner-take-all dynamic, and that could be potentially quite an unstable situation. But then this person said, we think we're going to go in a certain direction, and the other guys are going a little more this direction, and the other ones are going this other direction, and these models will have different strengths, and people will probably use all of them. They'll be more intentional about which model they use for which case. Is that basically the same sketch you are outlining on the creative side? Do you think you'll be distinctive in what you offer? I wasn't sure if it was that or if it was more just, we think we have insights that will save us on the compute budget.
I hope that's the case, that what you're saying is true, that there is going to be more diversity of different models, because I do think we're not collectively as a field exploring all the different kinds of models that you can scale. I think we're focusing on a very narrow set of tasks that we want them to get good at. So back to your question, I think it's a mix of both. Even at the same tasks, you can find some insights that will give you large algorithmic improvements, but it's more about what you want your final model to like what tasks you want to perform, essentially. And being very specific on that really pays off, even at scale.
How do you think about the kind of tension that exists between private company interests in novel architecture versus disclosure at a paper level, just for the world at large, given that AI is such a kind of big ball of mystery to so many people. What is that like for you guys, and how do you think about that?
Yeah, so I think it's important to publish findings and making sure that the collective understanding of available techniques, there is not too much kind of difference between the general research like knowledge versus the knowledge within individual companies. But there needs to be a balance because of how quickly the field is moving, how competitive the competitive situation between different companies. You can't necessarily publish every single aspect of what you're doing. I think you need to, for strategic reasons, maintain some level of specific insights and things that you found work really well for some period of time. There's a balance to be found of what you can reveal publicly to help kind of uplift the whole field and insights that help maintain some company lead.
So maybe there's a statute of limitations or something similar to copyright on our AI future.
I mean, knowledge gets diffused eventually. People move between different companies, kind of things in sufficient time become kind of known. And I would say for us, a big motivation and focus of the team is building tools that empower artists and creators. So that's ultimately how a lot of folks on the team see as where the biggest satisfaction and reward comes from. It's been less of a focus of getting to things that might have novelty as published research versus things that deliver really great tools.
I want to ask one very specific, somewhat selfish question, but I do think it is something that a lot of people are probably wondering. And that is, when do we get an API? How do we integrate this into our apps? For Waymark specifically, because we serve small businesses, image to video is the number one use case. Every generative tool we've tried for small business, we're always like, even if it looks sweet, they don't feel like it's going to represent them in a way where when customers come to the business, they're going to feel like this was the business they saw on TV. So image to video is the specific subtask that we are most interested in. There's probably also a lot of appetite out there for vertical because so many of the images that we take and so much of the video we watch is vertical. So give us a quick rundown of that, and specifically, how do we get off the API waitlist?
So we have done some initial work on the API side. We have a few customers that are using our API. Canva is maybe the one we've announced, but there is more in that pipeline. I think our main consideration is getting it right. We want to make sure that we have that API available it in a form that makes sense for folks to integrate with, but it's something that it's in the near future. And we want to make it more broadly available. I think we can't build all the possible tools around those models. You might have specific use case that makes sense for your users. We want to give access to those models in other ways. And that's something we're actively working on.
All right. Expect a follow-up by email from me on that. Time is short. If you have any comments on image to video, I feel like that has proven hard for almost everyone. I'm curious if you have any insight into why. In general, when I do a text prompt, I feel like the coherence and overall quality is typically better, not just on Runway, but pretty much all of the products that offer either text to video or image to video. I feel like I get a video that as a standalone asset is more coherent, overall better when I do the text prompt versus when I do an image prompt.
Interesting. Yeah, we've seen different folks find more value in one or the other. I think image to video, in some cases, is a much easier task, and in some cases, a much more difficult task. It's an easier task in that the model doesn't have to imagine the semantics of the scene, like the overall composition, and you can just focus on the motion. It's a more difficult task because it needs to respond to a wide range of possible inputs that it might not natively perform well with. So that's the reason why in some cases I think it can perform better depending on your use case from text to video. In some cases it might not generate as coherent motion and so forth.
Cool. Any final thoughts?
No, really great discussion. I think I really enjoyed both sections of the conversation.
Cool. Well, we appreciate you taking the time to do it. Fascinating perspective from you, and really got a lot from it. So for now, I will say Anastasis Germanidis, CTO of Runway ML. Thank you for being part of the cognitive revolution.
Thank you.
It is both energizing and enlightening to hear why people listen and learn what they value about the show. So please
don't hesitate to reach out via email at tcr@turpentine.co, or you can DM me on the social media platform of your choice.